Okey, Assalamualaikum. Nama saya Muhammad Aman bin Suri dan nombor matrik saya D33DPE 20F2 2014. Okey. Saya akan membentangkan kami ambil chapter 3 iaitu Mega Methanol Technology. Okey, first has been developed for work scale methanol plant with capacity large than 1 mmTA. Next, a special process design is needed incorporating advanced but proven and reliable technology cost optimized energy efficiency and low environmental impact. Okay, the main process feature to achieve this target are first, have a oxygen blonde, natural gas reforming, ether and combination with steam, methane reforming or as a pure autothermal reforming. Then, two-step methanol synthesis in water and gas co-reactor. Then, adjustment of syngas composition by hydrogen recycle. Okay, for configuration mainly depend on the feedstock composition which may vary from light natural gas nearly 100% methane content to oil associated gases. Okay, the aim is to generate an optimal synthesis gas. Okay, the Laji megatonal process have five. First, desulfurization, preforming, saturation, methanol synthesis, and methanol distillation. Okay, then this one process description. Okay, PFD. Okay, then first desulfurization to protect the reformer and synthesis catalyst from sulfur poisoning. The feedstock must be desulfurized. Desulfurization operate at approximately 350 to 380 degrees Celsius in the desulfurization reactor. The feedstock is rolled through zinc oxide bed where hydrogen sulfide is absorbed according to the following equation. This one have that one the equation. If the feedstock contain organic sulfur compounds such as mercaptan or thiopine is required prior to desulfurization, where the feedstock after adding a small amount of hydrogen-rich methanol synthesis push gas is hydrogenated over cobalt molybdenum catalyst. Okay, a residual sulfur content less than 0.1 ppm is obtained and can be tolerated for the downstream process. This one is important. It's a chemical. Okay, desulfurization ni is a chemical process for the removal of sulfur from a material. Okay, the last one for me, saturation. The natural gas feed gas is cooled and then enter the top of a saturator. For saturation, which water supplying a major part of H2O required for the reforming reaction. After make up with process condensate and process water from distillation, hot circulation water is fed to the top section of the saturator. Circulation water is withdrawn from the bottom of the saturator by recirculation pump and then is heated by a circulation water heater in the reform gas cooling train before it is referred to the saturator. Pause ke stop?
Hello, Assalamualaikum. My name is Syed Rafael Muhammad Noor. Um, so, um, pre-reforming optional. If the feedstock contain fraction of higher hydrocarbon, the steam record former catalyst can be affected by carbon deposit owing to cracking reaction with operated at low steam carburation. This should be avoided by preforming the feedstock in a preformer. The conversion of higher hydrocarbon in a diabatic reactor produce a gas rich in methane and hydrogen that is perfectly suitable for further steam reforming. The fixed bed type pre-reformer is arranged between the process field superheater and the steam pre-reformer. The desulfurized feedstock with processed steam add is route through the catalyst bed with almost all higher hydrocarbon and a small percentage of the methane are reformed with steam. So the equation, steam reforming of hydrocarbon CnHn plus NH2O and CO plus M over 2 plus NH2. Methanation CO plus 3H2 CH4 plus H2O. And water gas shift reaction CO plus H2O CO2 plus H2. So next, pre-reformed gas is produced at about 330 to 440. The overall heat balance being slightly endothermic and exothermic dependent on the content of higher HCS in the feedstock. The preformed gas only contain a few parts per million of hydrocarbon higher than methane and allow reduction of the steam to carbon ratio for the steam reformer to 1.8 A flow steam to carbon ratio. Superheating pre-reform upstream of the steam reformer will reduce the size of the steam reformer significantly. Additionally, the amount of water heat is reduced by saving steam reformer and the firing when combined reforming is used. Autothermal reforming. Pure autothermal reforming can be applied for syngas production in mega methanol plant whenever light natural gas is available as feedstock to the process. The disfire and optionally pre-reformed feedstock is reformed with steam to syngas at about 40 bar using oxygen as the reforming agent. The process offers great operational flexibility over a wide range to meet specific requirements. Reformer outlet temperature are typically in the range of 9050 Celsius to 1050 Celsius. The syngas is compressed to the pressure required for methanol syngas in a single casing syngas compressor with the help of a proprietary and proven three-dimensional compositional fluid dynamic model. FIG 2.2 gas flow and temperature profile are simulated with the objective of designing burner and reactor as an integrated unit. Autothermal process produce the heat required for gasification through the partial combustion of the feed gas to be converted in the reactor. Oxygen is usually added for this purpose. Suitable feedstock for autothermal catalytic reforming are like natural gas or steam reformed gas with a residual methane content. So chemical reaction, so combustion of methane CH4 plus 2O2 CO2 plus 2H2O. Partial oxidation of methane CH4 plus O2 to product CO plus H2 plus H2O. The combustion partial oxidation is highly exothermic, the reform reaction being endothermic. In order to attain the desired product gas quality, the outlet temperature of the reactor is selected and controlled by metering is in the required amount of oxygen to maintain the heat balance between exothermic and endothermic reaction. The autothermal reformer is a refractory line pressure vessel. A cross section of an ATR is illustrated in FIG 3.3. The lower cylindrical part of the ATR contains reforming catalyst. The entire ATR shell is protected by high temperature resistant braid lining. A mixer in the ATR top section provides fast and uniform mixing of the gas steam with the preheated oxygen. The combustion pre-reaction zone is located above the catalyst bed. The catalyst employed is a steam reforming catalyst because the operating condition establishing a stable flame control is essential to protecting the reactor with wall and catalyst from excessive temperature. Even when using pure methane as feedstock for autothermal reforming, it is necessary to condition the synthesis gas because the isotope number is below 2.0. The most economical way to achieve the required S composition is to withdraw from the methanol synthesis purge steam by a membrane with a pressure swing automation unit. Compared with the competitor, Logi has the most reference and experience for this reforming technology. This process has been implemented in Logi plant since the 1950.
Combined reforming. Maksud dia, combination of oxygen blow autothermal reforming and conventional steam methane reforming, the so-called combined reforming process. In a steam reforming process, hydrocarbon and steam are catalytically converted into hydrogen and carbon dioxide. The composition of the product gas is reached according to the following equilibrium reaction, which is CnHm plus NH2O equal to NCO plus M per 2 plus NH2 CH4 plus H2O CO plus 3H2 dan akan mendapat CO plus H2O CO2 plus H2. The overall reaction is highly endothermic, so reaction heat has to be provided externally. Synthesis gas is characterized by a relatively low pressure and a surplus of hydrogen. Adding carbon dioxide, the composition of the synthesis gas can be adjusted to be more favorable for methanol production. The advantage of combined reforming. Advantages: easier noise abatement, multiple tube rows resulting in a lower number of burners and lower heat loss, almost uniform wall temperature over the entire heat tube length, easier burner adjustment and reduced maintenance, less NOx formation. The features of this reforming design are advanced inlet pigtail design, internal insulation at the top of the reformer catalyst tube, counterweight tube support system, flexi-tube outlet system. The optimal stoichiometric synthesis gas composition can be achieved by choosing the appropriate bypass ratio. Since less than half the feed gas is routed through the steam reformer, the overall process steam requirements are also roughly half compared with other processes that use an autothermal reformer downstream of the steam reformer without such a bypass. The lower process steam consumption translates into reduced energy requirement and lower capital costs. Methanol synthesis gas generation by means of combined reforming is a well-proven technology. For natural gases or oil-associated gases with a methane content above 80%, and for methanol synthesis with capacities above 1500 mtd of methanol, this process route offers potential capital investment saving compared with a conventional steam reforming process. The composition of the generated synthesis gas is characterized by the stoichiometric number Sn equal to H2 minus CO2 over CO plus CO2. In the steam methane reforming process, the given CH ratio of the natural gas and the hydrogen added by steam decomposition leads to a stoichiometric number that is higher than optimal for methane production. For methanol production, the surplus of hydrogen would have to be compressed and behaves as an inert gas in the synthesis loop. It increases the size of the equipment and has to be discharged with a purge gas. In autothermal reforming, the heat required for reforming is generated by partially combusting feed gas. Now we will talk about waste heat recovery. Fuel gas cooling section. When combined reforming is used for the syngas production, the fuel gas leaving the steam reformer tubes are routed through a duct to the flue gas waste heat recovery section. How to use the sensible heat of the flue gas? Several heat exchanger tube banks are arranged in series. The feed preheater is arranged at the outlet of the reformer. Superheating of high and medium pressure steam is achieved. Reform gas cooling section. Reform gas leaving the base of the ATR at approximately 950 to 1050 represent a considerable source of heat with a potential for energy recovery. Gas enters the water heat boiler to generate saturated high pressure steam. The waste heat boiler is horizontally arranged cooler with fixed tube sheet connected to the high pressure steam drum by risers and downcomers using natural circulation system. Reformed gas leaving the waste heat boiler is cooled in the natural gas preheater while simultaneously preheating the natural gas. Reformer gas leaving the natural gas preheater to the circulation water heater. Further cooling is performed in the distillation section. Final cooling to syngas compressor section is temperature set temperature is achieved in the final cooler. During the process, the gas temperature drops below the water dew point. Separation of the process condensates is achieved subsequently at the saturated reformer gas is routed to the methanol synthesis unit.
Okay, now I'll be presenting on methanol synthesis. Before that, let me introduce myself. My name is Muhammad Hafi bin Nasri, and my matrix card number is 33DPE 20F2025. Okay, today I will be explaining on methanol synthesis. Okay, so on methanol synthesis, Luigi Mega Methanol once says that the process of methanol is synthesized from hydrogen, carbon monoxide, and carbon dioxide in the presence of highly selective copper-based catalysts. So the equation for methanol synthesis is going to be CO plus 2H with the power of 2 is equal to CH3OH, or it's going to be CO2 plus 3 hydrogen is equal to CH3OH plus H2O. So these reactions are highly exothermic, and the heat of reaction must be removed promptly from its sources. This effect accomplished most effectively throughout the Luigi methanol reactor. Okay, so proceeding on. So, the efficiency conversion or in the methanol synthesis unit is essential to low-cost methanol production. It is also optimal use of the reaction heat offers cost advantage and energy saving for the overall plants. Nowadays, there are two types of catalytic fixed bed reactors are used in the industries. One of them is going to be steam raising reactors, and the other one is going to be gas co-reactors. So the Luigi water cooled methanol reactor, or WCR, is basically a vertical shell and tube heat exchanger with a fixed tube sheets. So the catalyst is accommodated in tubes and rests on a bed of inert material. So other than that, we're gonna proceed to methanol synthesis loop. So throughout this topic, it's gonna be synthesis is economical conversion of the synthesis gas to methanol cannot be achieved in three stages, which is a single reactor pass. Second, unreacted gases are circulated in loops, and thus increasing the conversion rate. So by that, recycling gas and synthesis are mixed and preheated in the trim heater by cooling the reactor outlet gases. So other than that, preheat recycled gas and synthesis gas are routed to the GCR. On the tube of the GCR, the reactor inlet is further heated to the inlet temperature of the WGR, which is astronomically 240 Celsius. So these are the figure for the methanol synthesis loop with distillation sections. So as you can see, there's divided into 6 categories, which is syngas recycle compressor. There's area for gas co-reactors, water co-reactors, also topping columns, and other than that, it's gonna be pressure pure methanol column, and also lastly, it's gonna be atmospheric pure methanol column. So there's 6 of these parts on methanol synthesis loop. So proceeding on. So the most important advantage of combined synthesis converts are, one of them is going to be high syngas conversion efficiency. At the same conversion efficiency, the recycle ratio is about half the ratio in a single stage. And also water cooled reactor. So by doing that, high energy efficiency, about 0.8 to 50 to 60 bars steam per ton of methanol can be regenerated in the reactor. In addition, a substantial part of the sensible heat can recover at the gas co-reactor. Also, it's going to be lost investment cost. The reduction in catalyst volume for the water cooled reactor, the omission of the large feed gas preheat, and saving result importing from other equipment due to the low recycling ratio translate into specific cost saving of about 40% of the synthesis. High single train is going to be also high single train capacity. The design of this two plant has confirmed the single train plant of capacity about 5,000 mtd and above can be built. So other than that, I'm gonna proceed with methanol distillation. So in methanol distillation, the raw methanol produced in the methanol synthesis unit contains water, dissolved gases, and quantity of undesired but unavoidable byproduct that have either lower or higher boiling point than methanol. The purpose of this distillation unit is to remove those impurities in order to achieve the desired methanol purity specification. So this can be accomplished through three steps, which is degassing. Other than that, it's going to be removal of low boiling byproduct, and lastly, it's going to be removal of high boiling byproduct. So this is going to be the figure of the three-column methanol distillation. So um, so these are the diagram for the methanol distillation, as you can see.